talked about the explicit world where you have formulas that depend on the position. We've got all these new little terms that have been thrown at you. We talked about a sequence is a list of numbers. We talked about the numbers within the sequence are known as terms. And within each term you have positions of those terms. And so the n value refers to the positions. But it could also refer to the number of terms you have in your sequence. And then the t sub n's refer to the position value of any given term. So like, for example, T2 is the value of the second term. T9 would be the value of the ninth term. We introduced, but didn't talk much more about it on Friday, also this guy right here. And this is what recursive formulas base themselves off of, is a previous term. Something that was ahead of the one you are currently trying to find. So that little subscript n minus 1 doesn't mean you take the tn value and then subtract 1 from it. It means go to the term that was ahead of where we are currently trying to find the value. So explicit uses position numbers. Recursive uses previous term. Did we talk about the two parts of a recursive? Did I introduce that on Friday also? All right, so recursive formulas, unlike explicit, has to have a two-part. First is called an initial condition, which is always stating the value of the first term in your sequence. And then the second part of the recursive formula is going to be kind of the rule part, the formula part that helps me get to the next value of my terms. So this is the one that must use previous term in it. So in that equation somewhere, I better see t subscript n minus 1. And if we're doing arithmetic stuff with recursives, I'll always be adding a difference to that value. And if we're doing geometric, we'll always be multiplying a ratio value to that ratio.
Where does the minus 7 come from?
In this problem right here? All right, where does the minus 7 come from?
Sorry, that's what you're decreasing by.
Yeah, exactly. That's what we're decreasing by for this. So in this first, this is one of the sequences we looked at on Friday, 27, 20, 13, and 6. And we said each of those terms, we're getting to the next one by subtracting 7. Subtract 7, subtract 7, subtract 7. And because you're doing the same thing every time, you said that this was a difference of 7. And so here we have an example of both of our definitions. We have explicit and recursive. And notice the difference. The recursive formula has to have these two parts to it. It must state the very first term value. I need that. Otherwise, the second part of the recursive formula, this will not make sense. I have to have some term to refer to when I'm saying previous term. So if I'm at term 2, I need to go back to term 1, and that's what would happen here. So the disadvantage of a recursive definition. In the explicit definition, if I say go find the 90th term in a sequence, you can just plug 90 in for n and go find out what the value is. You can't do that in a recursive one because I always need the previous term. So it's not user-friendly that way. If I want to know the 90th term of a recursive formula, I have one or two things I can do. I can see if I can rewrite that thing into an explicit formula, which sometimes you can, sometimes you can't, and then use that to find the 90th term. Or I got to go find all 98 terms before I can find the 99, 89, which is kind of a bummer, right? I would like that. But the explicit would be nice if I knew what the explicit was.
Let's just add 7 to the deal. Subtract by 7. So.
Well, wait. What are you talking about?
So how you make the definition? You just take whatever it's doing, do that to the first term, and it's right. Whether it's.
Are you talking talking about for writing the explicit formula from the recursive? Yeah. Exactly. Yeah, if I want to write an explicit formula from the recursive, there's two things I can do. I already know what T1 is. There's T1, 27. So remember the explicit formula, and again, you're going to need to know this for tomorrow, is T1 plus n minus 1 times D. And there are two things you need to plug in for this formula, T1 and D. Well, we already know what T1 is, 27. Now, n minus 1, we leave it alone. And D, well, we looked at the sequence, or you can look at the recursive formula and see the D right there, if I know it's arithmetic. And I know it subtract 7 each time. So if I did that and I distributed negative 7n plus 7, that's where this 34 minus 7n is coming from for the explicit formula. So yes, I can write the formula of an explicit definition if I know previously the recursive definition. If it's arithmetic or geometric. What was that? Yes! Hey, who's the drop there? Hey, let me see. Is that a medium? True. Oh, no, you want. Obviously, you want velocity. Yes. Hands. That's not hand. No hand?
It's not right here.
You got it.
Why isn't it just 7? You're not right.
Correct. Because I'm not adding up subtracting. There was an addition and B plus. All right. Any other questions on recursive definition? All right. So let's try some of these. Here we have our recursive formulas given to us. It's kind of, the notation's a little different. It's a side-by-side notation instead of a kind of a stacked notation. So another way you would see these written is this way. You would write the recursive first term value above the formula part of it. All right, so we're supposed to find the third, fourth, the fifth, and then classify whether these are geometric, arithmetic, or neither. And then go find T10. So that's where the bummer comes in. Since it's recursive, I need to find T of 9, which means I need 8, which means I need 7, which means I need 6. So let's go after these. We know we have 10 terms. What would T1 look like? Well, T1 is already given. T1 is 2. That's my initial condition. What would T2 look like? Well, T2 would be, according to this rule, 3 times T of 2 minus 1, meaning I'm actually looking at the previous term 2, which would be 1. So 3 times term 1 is what that means. And we know that term 1 is already a 2, so this is 3 times 2, or we get a 6 for T2. So far we got 2, 6, where's this all out here? How do I know how far I go? Because I'm looking to find T10. All right, so T3. T3, what's that going to be? Well, it's going to be 3 times T of 3 minus 1 now, which is really T2. And T2 we know is 6. So that means my third term is 18. And then I'm just going to keep rolling on with this. So what does this one look like? Geometric, because I'm doing the same thing, which is a multiply by 3 to get from one term to the next. So this is a geo with an R value equal to 3. Now look at the equation. In a geometric recursive formula, you will see the R value, just like you would in an explicit geometric formula. There it is right there. There's my 3. Telling me I'm multiplying by 3 each time. 3 times, and then the previous term. That's the giveaway that I've got geometric going on. So we just keep going. We have find out, if I want to find t to the 10th, so again, the bummer is, for me to find t10, I need to know what 3 times t9 is. But I don't know t9. So we would just have to keep going here. 54, 162, and then 300 plus another 186, 486. Check my number here. And then 1200 plus another 240. 1440 plus another 24, 1464. How am I doing? I'm doing all right? And now I'm going to get 3,000 plus another 1,200. That's 4,200 plus another 180, 4,380 plus another 12, 4,392.
Yes.
And then 1,200 plus another 9. That's a 21 plus another 2,700. That's another. Let's see. Not 27, 270. That would be 2370 plus another 6, 2376. No. 12, 376?
13, 1.
Ah, right. 176. All right, and then this next one.
Wait.
You're right, that is not a 6. Just making sure. I messed up.
Yeah. It should be 1458.
Forgive me for trying to do it in my head. Okay. Okay, and then okay, how far are we at? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, good, one more.
39,000.
Okay, so there's my T10. 39,366. What a bummer, huh? Doesn't that kind of stink to do it with the recursive? So again, how could I have done this differently? I could put it in an explicit formula and then go find T10. All right.
So, what would the explicit formula?
What would the explicit formula be? It's a great question. What would the explicit formula look like for this? T sub n is equal to, remember the generic explicit formula? T of 1 times r to the n minus 1. So in this case it would be 2 times 3 to the, if I'm looking for the 10th term, 10 minus 1. Say that again. Okay, what about this one? What are my, okay, we'll start, I'll give you the hard one. There we go. Now you get the rest of them that are easier. T2 would be equal to T of 1 plus 2, because that's the position we're in. These two will match. Whatever the n values are going to match. So what am I going to get there? What do I get plus 2? It says to, in the formula it says to add in. So remember, this is position 1, position 2, position 3, position 4, and so on. So this is going to be a 3, right? And then I'm going to get another, what's going to be next? Oh, hang on now. Is it? Is it a 5? Remember, this is only a 2 because that's what position we were in. So T3 is going to be T2 plus 3 now. So it's 6. What? What was your question about? You see why it's doing that? And the next one's going to be 6 plus 4. And then 10 plus 5. And then 15 plus 6. And then 21 plus 7. And then 28 plus 8. And then 36 plus 9. And then 45 plus 10. is that one arithmetic?
No.
Is it geometric?
No.
Because there's no common difference, there's no common ratio, this is neither. And here's the big giveaway. This is really the big giveaway. Whenever you're adding a variable, and that changes because of position number, that number is never the same number. Now, if that had been a 4 plus 4, then this would have been arithmetic. Yes?
Are we going to have to find, like, equations for either non-arithmetic and non-geometric for the one quiz?
Yeah, so we had some of those on Friday. We had one that was like a 1, 4, 9, 16, 25. Not arithmetic, not geometric, but you could still find the equation. It relied on the position number, right? Yeah. Yep. So yes, the answer to that is yes.
Awesome.
All right, so this next one, why don't you just tell me what it is? Arithmetic, geometric, what's going on right now? And we know it's arithmetic because I'm subtracting 3 from the previous term every time. Start at 20, then you get 17, and you get to 14, and so on and so on. So that one would have been arithmetic. This one we set up here is neither. All right, so that's that stuff. Let's go to check out the geometric. So now we're looking for recursive definitions for these arithmetic. Oh, wait, didn't I say geometric? What did I just do? Oh, the other one was just like find out what kind it is. Okay, these are specifically arithmetic. So now we know we have some difference in between. All right? So the thing that this is often left off for our recursive formulas, what do you think, Louis? Let's think. T1, yeah, we oftentimes leave the T of 1. Can't leave the T of 1, that's a part of my formula. I have to state T1 is equal to blah, and then write my T of n equation. So we can see each of these, something's going on with some sort of a difference. This one we know we're adding 3 here, subtracting 20. We know recursively that I have to start with T1 equals, in this case 4. In this case, T1 equals 90. And now we just need the T in parts. Well, they have to do with these T's. So who's got the rule for me here for A? What am I going to be?
You want the T of n minus 1.
Yep.
Okay.
Yep.
T of n minus 1.
T of n minus 1
And then plus 3.
plus 3. So just be careful when you're writing this n minus 1. Write it as a subscript number. Don't write it right next to the T because then it looks like it's a distribution to a binomial. So write it as a subscript number. So this then would be, this is what I'm going to have to see for a recursive formula. Is those 2 parts. All right, let's kind of skip B because, well, let's just skip it. Now this one, the C is a little more challenging. So look what we're doing now. So I give you the first term, and then I give you the nth term. And so you have 11 terms.
Is it S1 or
Oh, that's a great question. What do you guys think? Is this that?
no? That is just a
Say that again. Okay, well, okay, wait. So if n of 11 is where 40 is at, then that contradicts what these guys said. No, this is not the 11th term. What do you guys think? Is 40 the 11th term? Yes, it is. 40 is the 11th term. How do I know that? T sub n, there's what n is. Because I want you to associate the fact that if I give you the number of terms, I'm giving you the Tnth term of the sequence. Right? So I know that I got the 11th term because it told me I have 11, and I'm looking for T sub n, which means go to the last number in the sequence, which means it has to be the 11th. So far we know this. 50, don't know 2, 3, 4, 5, 6, 7, 8, 9, 10, but we do know 11. And we're supposed to write a recursive formula about about, now remember, this is arithmetic. It told us that this is arithmetic. So it must have a common difference. So now, the question is, how do we go about finding that? Okay, we guess and check. Yeah, you can guess and check. There's a way to do it without guess and check. Yeah. You don't have it?
Make two different equations and substitute.
Okay, now when you say two different equations,
Make T of 1, make the T of n, and the T of n. I'll create a formula. I don't know how to explain this.
okay, if I do two different equations though, remember that in my equations for a recursive formula, I need to rely on Tn minus 1. Correct? So let me see if this is what you're saying. So Michael, if you're saying we're going to go find the second term, for example. I know T of 1 is equal to 50. So T of n minus, or T of n being the second term, would be T of n minus 1 plus some b value. Correct? Generically speaking. Is that right? All right, and then let's go over here, because I looked at those first two terms. What if we look at the last term? That's T of 11. And that's going to be found by some previous term plus d also. But I know T of 11 is equal to a 40. So my question is this. If I know T of n, which is T of 2, I don't know it. I know the previous term to this was equal to a 50. Do I have enough stuff to be able to... Yeah. Okay, all right, yeah. So intuitively you can look at it and go, decreasing by 1, but how do we mathematically show that?
Just average it.
Okay, if I average it, is that what you're going to say, Parker? Is that what you're going to say? Okay, let's look at averaging. So if I average this between 50 and this is called an arithmetic mean, by the way. You might have seen that problem in your homework. Arithmetic mean. Did you guys see that? Arithmetic mean. There are two types of means. There's arithmetic and geometric. Arithmetic is when you're wanting to find what's happening, like the middle value of two numbers that are adding together or subtracting. And a geometric is when you're finding what's the middle of two numbers that are multiplying. So arithmetic would say, let's add them up. Say, take some, in this case, T1 and T11 divided by 2. We get 45. And that's the middle term between here. There's 11 terms. So 1, 2, 3, 4, 5. There's the middle right there. 1, 2, 3, 4, 5. So this has to be a 45. But, I mean, yeah, intuitively you can get, okay, look at it. Start at 50 and then go to 45. This isn't rocket science. I'm going down by 1. But if I try this again, between, let's say, 50 and 45, well, now I'm going to land right there in the middle with two values, which isn't a term in my sequence. So there's another way that I can go find this D mathematically. Yes?
Well, couldn't you just say that the difference between 50 and 40 is 10?
Yeah.
And the difference between their places are, whatever, the T1 and T11 is 10. So you can just say 10 divided by 10 is 1. And it says you know it's subtracted from 50.
Okay. Yes, you can. But how about we use this? You're all right. You're all absolutely right.
But
So here's the deal. First, it's arithmetic. Correct? Which means it must have a common difference. Can I use this to help me with my answer? If it's arithmetic and it has a common difference, that formula is for an explicit, which I know has an arithmetic common difference. And do I have all of these parts to be able to find D? And the answer is yes. I know Tn is a 40, and T1 is a 50. And n, we know, is 11. So this is what Corbin was just getting at. So if I subtract the 50 and get a negative 10 is equal to a 10D. And divide by 10, I get difference is a negative 1. So I can use my explicit formulas only because I know it has a common difference, and the only other formula I know that has a common difference is an explicit arithmetic. I can use that to help me go back and find this thing. So now I know what my D is. We can go and make our final, what were we looking for, by the way? Just the rule, right? We're looking for the rule, because I needed D to be able to write the rule. So here's my rule. T1 was 50. Tn was equal to previous term minus 1. I just needed the D to be able to write that. So anyway, mathematically, that's how we can do that. But you're right. I know I had 11 spaces, 10 in between, 10 divided by 10, 1. I'm decreasing, so I'm going down each time by 1. But there it is. That's just proof of it. All right, what questions do you have on that? Does that look too complicated? No? All right. Anyway, we talked about those in the homework on Friday. I don't know if we didn't do much more beyond that. So here they are. We probably already come up with this conclusion on our own, but here are our two formulas then. These are the other two you're going to have to stack with the ones we did on Friday. Our arithmetic and our geometric recursive formulas. They look a lot alike. Start out with some known value. These can be t's, by the way. T of 1 equals T of n is equal to T1 plus a difference. T1 equals T of n equals T of n minus 1. Whoops. Times an R. This has to be a T of n minus 1 here. So those are the other two. So let's just do a couple of these. How about we do, let's just do B and C here. B and C. This is now, these are geometric. So let's see if we can find out the rules we get for these two geometric sequences given this information. All right, so the first one, you recognize going from one term to the next. I'm doing the same thing, which is a 1/3. We're dividing by 3. I know it's recursive, which means I'm going to start out by stating the initial condition. The second part of the formula uses the previous term. In this case, I'm dividing it by 3. Or you could write it like this: 1/3 times the previous term. One of those would be my rules for that one. This one, again, not so obvious. We're going to have to go back and rely on this formula. I'm going to use that guy to find my R value. Okay, that's my explicit formula of the geometric, and I know since both of these are geometric, I can use that. So we use T of n, which in this case is T of 6, because that's my last term. And T of 6 we know is equal to 3. And that's supposed to equal T1 times this R to the 6 minus 1 power. So then we just have some work to go find R. To divide by 96 and get 1 over 32 is equal R to the 5th. And now we're going to take a 5th root of everything and get 1/2. All right, now we found our R. That means I can now write my rule for the recursive formula for this thing. T1 T1 equals 96. T sub n is equal to previous term times r. I'm going to put the r in front. So we can write it like that. Well, you mean, does it matter if I put the 1/2 on the end or divide by 2? No. If it's a non-fractional number, let's just put the coefficient part in front. Yeah. All right, there we go. Little recursive work there for metrics. You doing okay? Let's just talk through this one. We're not going to necessarily do it. What kind is it? Arithmetic. What's my difference? 3. So I can write my recursive as, who's going to give me the recursive? Okay. T equals 5. There you go. Good. Somebody give me the explicit. What's the explicit look like for that? Tn equals what?
5 plus n plus 3.
Close. 5 plus n minus 1 times 3. And then I have some work to do. Remember, on your explicit formulas, I want you to simplify them. So don't leave it like this. Don't leave it like that. Distribute and combine my like terms. So there's what I'm looking for arithmetic stuff. I can't control the arithmetic. Sorry. What kind is this?
Recursive definition of the one we just got today, right?
Recursive definitions are the ones we got. This is geometric with a ratio of 2.